Hello, everybody. Welcome to Mankind in Training. I'm your host, Joshua Parr. I know I said I was going to come with a part 2 of the sci-fi video before I released anything else, or a deep dive into C++, but today I'm going to do a quick rundown of Sympy, something I come across and am very impressed with. So I made up a quick demonstration of some things that I was working on earlier and just kind of brought them over for everyone else to view. So I'm going to share my screen now. Here we are in the Jupyter Notebook. Sympy is a symbolic Python language. It's super duper powerful. I'm just rather impressed. I'm not going to lie. It's impressive. So this is a Finley Analytics and Data Science Mankind in Training tutorial with your host, me, Joshua Parr. So the first thing we're doing here is importing Sympy as SMP, importing NumPy as NP, importing Matplotlib as PyPlot, Matplotlib.pyplot as PLT. From Sympy, we are importing star. And we're going to run that. If I don't run that, it's going to give me errors because I didn't import Sympy. So the very first thing I'm going to do, just as a demonstration to show you what's going on here, you're going to take anything you want to make into a symbol that you want Sympy to recognize, X, Y, Z. You can use the Greek letters, delta, psi, nu, mu, all. You can put whatever you want there and add it into the Sympy symbols. And once you've done that, you can create expressions. So, how about that? You like that? It likes that. I was missing an M. So now you can do things like this. X minus Y squared. Where are we at here? There we are, minus Y squared minus cos X minus Y. And if I run this expression, I get the expression now that it's recognized X and Y as symbols. And now I can evaluate this expression, or I can save this expression as express equals this. And if I want to, so I've saved that as a variable, express. So now that I have X and Y has already been enabled in symbols, I'm going to take a limit. This is how you would do that with the smp.limit function. And I'm taking the limit of 2 times the exponent 1 over x divided by the exponent 1 over x plus 1. X and 0, positive. And it's given me my limit. So now I'm doing what I did above. We are telling Sympy I'm putting in a bunch of symbols, and I want you to evaluate them. X, Y, Z, nu, the Greek letter nu, Q, delta, the Greek letter delta, P, xi, the Greek letter xi, and T. And you write them all just like this, spaced out here, but commaed in between here. And in this case, I'm saying that all of these symbols are real numbers, and they are positive numbers. That's what I want the answer to be. We're going to run this. So now Sympy has evaluated that these are expressions. So now I'm going to differentiate x squared times y squared divided by z times nu plus xi times q with respect to x, differentiating with respect to x. And bam, gives me the answer with the quickness. 2xy squared over nu z. So now that I have my answer that I was looking for earlier, I did this. I needed to get some more expressions built into Sympy. And I'm going to run that real quick. So now Sympy has all x, y, z, and now t, q, z, psi, tau, omega, r, l, and g. These were variables I needed for the next thing I was doing. So now I'm going to take an integral of 2 times, or 2 divided by the square root of t minus x squared times tau plus 1 divided by y squared plus y divided by nu times z. And I'm integrating with respect to x. Sometimes it takes a minute because that was quite a doozy actually. It's amazing that it did it as quick as it did. And it come up with, now I did not specify that they were real and positive. So now I get, when you don't specify, it's going to give you a variety of answers. This could be a solution or this could be a solution. So we got 2 tau, negative I, a cosh, and then x over the square root of t, and then a sine x over the square root of t for x squared over the absolute value of t being greater than L. Otherwise, it will be x over y squared plus x by z over nu. Now that I've gotten my answer here, we're going to integrate a different function. Now I have xi minus cosine of L times x minus t squared divided by x squared minus y times z times 2 times tau divided by omega times nu. And now I'm integrating with respect to time. Bam. So fast. We got the answer. It is negative 2 nu t cubed tau over 3 omega x squared minus 3 omega yz plus t negative x cosine L plus psi. So now I'm going to add some more symbols. Man, I love this. This is just, I'm like a kid in a candy store. I've heard of Sympy, but I didn't realize quite how powerful it was until the other day. And I thought I kind of needed to share this. I'm sure there's other people that are quite aware, but I wasn't. I knew what it was. I had heard of it. Anyway, now we are creating some new symbols: A, P, L, E, X, Q, kappa, D, Y, J, and I. J and I are indices. Theta equaling. Oh yeah. Theta is also another symbol, and then we're gonna go equals SMP symbols, and then I got everything I just listed. I gotta run that. If I don't run that, it will have an error because I didn't define kappa or A. So now I'm differentiating A times delta minus P divided by D times T squared minus Q times L times theta minus E squared, E to the X divided by J plus Y minus P plus kappa. And we are differentiating with respect to A. I'm trying to get a derivative. A, and it gave it to me quite fast. We have delta negative e to the x over j minus p of x plus theta plus y, which is exactly what I was looking for. And now I'm trying to different function. differentiating again. I'm getting the derivative negative I times a cosh of x over the square root of t minus r squared times pi times a sine of x divided by the square root of t plus x divided by y squared plus x times y times z divided by nu and, and differentiate with respect to tau. This is a crazy function. Bam. That is mind-blowing. This is not easy to do at all by hand. If you can do it by hand, even I wouldn't even opt to try to do that. So now what we have here is a symbolic expression. And what it is representing is a series, a summation, and what I'm going to do here is I have this. Now I'm going to SMP.sum, capital S. That'd have been not good. And now we have what I was looking for, actually. But now I actually want the answer to this. This is the expression I was looking to pop up. Now I need to go dot do it. Huh. Wonder what happened there. Oh, it did do it. It did do it. That is different. Okay, so now I am adding n into my symbols. And I'm creating another expression here. That is how you would write out a summation. Now, if I want to do it again, go dot do it. And there we are. We have 10 over 3. Beautiful. So, again, I have another sum. And I want the answer. Oh, and SMP.rational, 11 over 10. That's how you write the fractions. Dot do it. Do it. And it didn't like that one. That's what you get. So now I want to find for n here. And it is taking some time. Sometimes these are hard. And they do take a while. Huh. Yeah, I wonder why that's not working. I'm going to stop it. Oh, no, it worked. It did work. It just took forever. Got 1.969, which is the answer. It's like, I did this earlier. It should work. But anyway, so now if you want to solve a function, so these are functions now I'm creating, and you have to put them into the symbols too. But you have to go class equals SMP.function. And I'm creating Q is Q of F, and F as F of Q plus F, and then P as P of F minus Q. And I would like to, I need to run this first. I would like to differentiate now. Why? Why don't you like that? Okay. It doesn't like that. So what we're going to do, since it doesn't like that, is do this one. It did like that. Oh, because I've already declared that P and Q were variables of a different sort, and it didn't like that. So, did run that, right? All right. Now, if I want to differentiate f of x, bam, I get d over dx. I get the derivative g of x plus 1, and then d over d of xi 1, maybe an L. No, it's a 1. Xi 1 and then xi 1 equaling x plus g of x. So, quick rundown. I'm not the authority of Sympy, but I just come across it after hearing about it for some time, and I am very impressed with the power. There's a lot of these things that I've been struggling with, I guess, and the computer makes them so easy. It's just outrageous. Once you understand the formatting of things, once you understand the mathematical components to some of these equations, it becomes a lot easier if you can solve them with computers. And with SymPy and SciPy and NumPy, these are all powerful tools, and I recommend you get to know them well. Because the more I get to know them, the more I'm like, wow. So thank you for watching, everybody. This has been a Mankind in Training SymPy Rundown. Your host, Joshua Parr, Finley Analytics. I'm going to stop my screen. Thank you, everybody who has liked and subscribed. I recently made a video about the ether. Now, Finley Analytics Origin Project is not trying to prove the existence of ether. I personally had the position that, well, it would be a lot easier to explain some of these things if, in fact, there was a medium in which that we could quantify. So I just had to clear that up. Finley Analytics is not looking specifically for ether, but I may have biased my own equations by also looking for ether, which may not help us out very much. But thank you for watching, everybody. If you'd like, subscribe. If you would like to see anything in particular, just message me. I have no problem doing a tutorial on anything. So, thank you everybody for watching. Have a beautiful night.